Hello and welcome to Thinking with Objects, lecture number 2, classes, packages and scopes. So the last time we spoke about the classes, what they were, how to create objects from them, and basically all the basic stuff that you can do. However, there are more things to learn, and furthermore, well, from experience, from personal experience actually, it's quite tricky to get a grasp of why and when to use classes, why not just use a ton of arrays and stuff like that. So just because of that, I'm going to show you a big example today. It's going to take up most of the time today actually, where I give you an example. I'm going to create a game, so to show you when and why you can use these classes to make it much easier to do things. And while we go along with creating this game, I'm going to introduce new things. So we have more things to learn about classes, and then in the end also packages and scopes. And to learn about that, I'm going to go through this example game. Right, I hope that sounds alright. So let's get started. So first of all, it's going to be a 2D text-based game, so no advanced graphics here. And what we want to do is a location class. So that's a location in the map. And to start off, we only need like the symbol in the map. So we need a character like this symbol, like so. And of course we need a constructor which is going to be called when we're creating the location itself. And I wanted to send along a symbol so we can store that for later. So what's going on here? Well, I have a parameter called symbol. I have a field called symbol. That's totally fine actually. You can do things like that because they access different areas. This field here can access all the methods, or well, can be accessed in all the methods, while this parameter here can only be accessed inside the constructor itself, like in here. So if I do things like this, like symbol, well, char symbol, then I'm creating a variable inside here, which is not going to work because then I have two symbols here in the same location. Let me set this up properly. There you go. So if I say this now and compile it, it's going to complain, well, we have symbol twice here, you can't redeclare it. If this want to behave. But what we will realize is that this symbol up here is totally fine. We can have that. So here we go. Variable symbol is already defined in constructor location, so that doesn't work. But when I remove it, it's totally fine. So the reason is because, well, they access different areas. This accesses just this small area here, while this can be accessed in the whole class. And right, what does this mean? Well, it means that this sort of becomes shadowed by this one. We can't really see the upper one, the outer one, because, well, we have a more local version. So, or if we would just do symbol equals b, for instance, then that's going to be stored in the parameter, not in the field up here. But that's not what we want. What we really want is to save this value here in that value there. So how do we refer to the outer value? Well, we can name it something else. That's totally fine, and just do like my symbol field equals symbol. That would be totally fine. But what do we want to call it symbol here? Well, that's also fine, but then we have to refer it differently, because if we just do it like this, we're going to tell the parameter to get the value of the parameter, so that doesn't really make sense. But what we can do is using this dot symbol. So that's going to refer to the object itself, the object we're currently working with, and then get that one's field called symbol. So all of a sudden we're referring to this symbol instead. So that allows us to save the this symbol that we're creating during the constructor. More to that later. We'll see some more examples on how we can do that, and some more examples of where we can use this keyword. And what we can do then is simply do a method called get map symbol, and therefore just return the symbol. So now we prevent ourselves, well, we tell ourselves to not use the symbol itself, but we just tell us that, well, we can read it from here, and we can change it, well, we can set it when we create it, but then we can't change it otherwise. So this location is going to be very, very simple to start with, and then it's going to be expanded. So let's create another class called map, and let's see if we can see some new things you can do in this class here. Okay, so the map is going to be a two-dimensional array, or well, like this. It's going to be a two-dimensional array of locations. So we have a location and two brackets like so, and then we have the name board. So that's going to be the board of our map, basically. So nothing weird here, just a field that we can use. And then we want some constructors, right? What do we do? Well, it would make sense to ask for the width of the map, and it would make sense to ask for the height of the map, and then just create a board accordingly. Because, well, it doesn't make sense to just have a board if we don't actually create it. So if we do it like this, we're going to create that. Observe now two things. First of all, I'm reversing these. So I have width and height here, but here I have height and width. The reason is, well, I've done something similar before, is that usually you can go with the x value first, so that's the width, and then the y value, that's the height. But when it comes to printing out lines in a text-based game, then it makes more sense to actually have the height as the outer one, because you want to print it out row by row rather than column by column, because that's very tricky, because, well, in the end you use a new line character, not a new column character. So that's just how you print things out. So that's why I do it in the reverse way. You might call it, or you might call it the correct way, it doesn't matter. So that's the first thing. And the second thing is, we don't really create any locations. We just have a board, and we create a location two-dimensional array, but we don't create the locations themselves. So this is going to be a map of this width and this height, but without any actual locations. We will have to add them later. And what we can do now is actually another constructor, because, well, what if we don't want to define the size of the map? We might have like a default size of the map, which we can use, and if we want to, we can just set it specially to a certain width and a certain height, like so. So how can we do this? Well, we can do like board equals new location, like 10, but this is a bit silly, because we're already defining how to create the board, how to create a new map if we give it a width and a height. So why not reuse this? Because the constructor is a method after all, right? So how do you refer to this constructor here? Well, we can do that with this keyword, so we can use it for this as well. Remember, we had it here when we referred to this field up there, but we can also refer it by doing this. So when we use this keyword here, we refer to ourselves still, but we refer to the constructor, and then we refer to the constructor with two integer parameters, which is this one. So when we do this here, create a map with a default size, then it's going to call the other constructor, call the other constructor to do the work. At the moment it's not that much, so we just create a board, and that's actually everything we're going to do. But if you had something more advanced, it's quite nice to just be able to maybe call the do something first and then call the other constructor, or maybe just use the other constructor to give it some default values, and and things like that. So it's actually very useful if you have, because think about it, if you have like 20 lines of code in the first constructor, and you have 21 lines of code in the second one, and the only difference is that first line of code, or that last one of code rather. So you want to then you can just do like this 1010, and then you do that final thing, set temperature 3, for instance. So you like create a new map, and the only difference you do is set the temperature, and here you do a lot of things like set humidity. So I don't know, you set like a lot of variables here, set wind. You know, you create a map with a lot of these different things, and then you might want to have a special one where you set something else as well. But then there's no reason to do those things twice, since, well, this is a method after all. It's a constructor which is a method. So therefore we can just use this to call another constructor, like that. Okay. We might want to be able to print out this board as well. So let's go with void print map. Right, and we've seen how to handle let's do it like that, two-dimensional arrays before. So I'm just going to loop through here, but when I do, we're going to see another new thing that we need to keep in mind that we haven't really covered. So first of all, I loop through the outer dimension, and then I loop through the inner one, like this. And then we can get the location, right? We can get the location at that specific position in the board. And that's done like that, right? We had the y value first, and then the x value, like so. And what we want to do now is, well, print out the symbol here. We can get the map symbol from the location, right? Okay. So how do we do this? So we can do location dot get map symbol, right? And what I want to do actually is having a string here called board text, which we add all the content to, and then we print it all out. So we can print it all out at the same time. It's more efficient than just printing it out one piece of text at a time, like that. But what we have to be careful of now is, well, if we just create this board, it's going to be empty. And if the board is empty, well, then we have something called null in it. Here, null, like that. And if we have null, we can't, if we have that value here, it's like telling it to do null.getMap symbol. And this doesn't work. If we don't have any value in location, we have no value that's null, then it's going to crash when we try to refer to something called the getMap symbol. If we, however, have a proper location stored in this variable, then we can use a getMap symbol without a problem, and well, just get the symbol. So what we'll have to do, because we don't know if the map has some empty spots in it or not, then what we want to do is make sure that if the location is null, that it doesn't really exist, then we want to add like a dot instead. I think that would work. So that means that, well, this spot is not occupied by a proper location. You should add it here, you know, and otherwise we add it like this. So this is making sure that everything is going to work like this. Right. So if we didn't do this check here, then it would basically crash. We would get something called a null pointer exception, which basically means that we try to refer to something from nothing. So if we have null, we can't refer to getMap symbol because null doesn't have that. So here we print out a missing location, and here we print out the map symbol. So as you can see here, I just have two different cases. One for if, well, we don't really have a proper location, and one if we have. Right. So now we hit compile there. So now we have a very simple map here of different locations. We can create them in two different ways. Either we create it with a given size, the width and the height, or we just create a new one and then it's going to use a 10 by 10. And that 10 by 10 thingy is going to be calling the first constructor. So we just tell it, well, create it with a given size, and I give you the size 10, 10. And then we can print it all out, but we'll have to be careful about making sure that the location we're referring to is not null. So that's a new thing there. Make sure that it's not null. And you will get null pointer exceptions all the time. It's very common to get. Right, so let's create the actual game now. Like this. Okay, so what do we want? Well, we want a public static void main string args, like this. And if we have so, we can just so how do we do it? How do we create a map? I want to create a map. So as we've seen before, we have just a variable here. That's just if you want to store it. And then I create a new map, like so. And I can do map.print map. Oops. So at the moment I'm using the empty constructor, the constructor without any parameters. And what that's going to do is, well, it's quite simple. It's going to use this constructor without parameters, but that's going to run this constructor with parameters, but with 10 as the first one and 10 as the second one. So if I run the code now, here, it's, oh right, it's not working. It's just printing dots all over the place. Why? Well, it could be good to actually add a new line character so we actually get this as a proper board. So if I use board text and then we add a new line character here. So that's going to make sure that after each row in the map we were actually adding a new line character, and then we get this. So at the moment we don't really have anything that could be called a game. We just have a lot of dots here. Right. So what will we add in the next step to, well, make this better? Well, one good thing to add would be a player. So I'm going to add that as another class here. And we can see an example of a few other things. So if I do public class player, well, like that. And then what I want to add is, well, first of all, a constructor, right? And I want to have a map, so the map the user is currently in, or that player is, and then a location, so the x, well, the position, the x and y coordinate of that player, right? Makes sense? We need to be somewhere, and yeah, we need to be somewhere in that map. And those things should obviously be saved, because we will just remember the values of these while we're inside the actual constructor, and they are to no use for us in there. Right. Okay. Map int x int y, and then I can say then exactly like I did before, right? So this .map, that's going to refer to this map there, rather than this. And then if I just type map, it's going to refer to this parameter here. Then I can do this .x equals x, and this .y equals y. So as you can see here, I'm using this keyword to refer to these things here, rather than these things to the right, where I'm not using this. But I want to have some health to the player as well, so we can set the health of the player. Observe now that I'm not using this. Why? Well, there's no reason to, because, well, I don't have any parameter called health, so I can just refer to the field by typing health. So this is perfectly fine. But if I would like to, I could use this as well, like that. So I can use this .health if I want to. There's nothing that prevents me from doing that. But it's sufficient to just do it like this. Or what I could do would be to remove that altogether and set the default value there. So if we have a default value of just one line, like we can just type it out directly, then if we want to now, we can just add it, because we've seen this before in local variables. Not with fields, but it's the same. So we can just have, like, the health starts at 10, so we can set it there. or we can set it here, it doesn't matter really. So I'm just going to leave it like this. So here we set the map x and y to store for later, and then also doing that, setting the health to 10 to start with. Then it might be good to be able to get the x and y, so we can use that somewhere else. But like I've said, we could still use these. Nothing is preventing us from doing that, which we will actually prevent us from doing in the end of this lecture. We'll talk about scopes. So that is something that we can use to allow us to reach these two things from another class, but not these things here. Right, so now we have a player, right? Player, what did it do? Let's take a look. There's two brackets up here, two curly brackets. There you go. Right, so when we print out the map, we might want to print out the player inside the map, right? And to do so, we simply check if, well, if we are at a specific location, if the player's x position equals our x position, and, well, that position in the map, and the player's y position equals the y position, that means that, well, the player should be here. And then we want to print out something else, because, well, the map is just based on characters, a 2D array of characters, and therefore we can't really print out the location as well as the player. So what I'm going to do now is, in the lack of a better symbol, I'm just going to use a P for player or person or whatnot. So now I can get the player as well. So print out the player like this. But now this won't work back in the game example here, because, well, now there's no constructor, which is well, not constructor, not any method called print map that takes no parameters, right? So let's comment that out for now. So now we can compile it still, but now obviously this is not going to print out anything at all. What we could do for making things easier, and you will see later on why it's going to be very handy for us, if I have something called like print in map, so we want to print a player inside the map that it's currently in, how do we do this? Well, first of all, it's quite simple. We just do map, that's the map we're currently in, right? That's that one. And then we do map dot print map. And what do we do now? So let's take a look in the map class. What's it doing? Well, it's asked for a player, right? So what's our player? We're currently inside the player class, and we're not in a static method, so we're currently in a specific player. We're referring to a specific player, and that's the player we want to print out in the map. So how do you refer to that? Well, you might have guessed it, I don't know. We just use this. So we can use this in three different well, ways. We can use it when referring to ourselves to send along as a value. We can store it in a variable. We can send it in as a parameter, so then we can refer to this. We can refer to this like that, where we just do this dot and then a field name or method name or something like that, which is very handy now when we have a field and a parameter that's called the same, so we can refer to the outer one just by doing this dot map. Otherwise we would just refer to the inner one if we just use the name directly. And then we had the third way, which we saw in map here, where we used it to call another constructor from within one constructor. So that's the three different uses of this. Either as to call another constructor, either to call well, refer to a field like that, or refer to ourselves like that. So it's always a well, we always refer to ourselves somehow to the own object, but exactly what we're doing is a bit different. Right, so now we can ask the player to just print itself out in the map, and I say why not? Why not do that? So player equals new player. So we need to give it something. We need to give it a map and then a location, right? So I'm going to spawn the player inside the map we create, and then well, spawn it at 2, 2 like that. and then player dot print in map. Right, and then we can run that. Here we go. So now we have a lot of dots still, but we also have the player here. So it's still not a game really. So we need to be able to move the player, and I think that's the next thing to add. Move the player, and now we will see some interaction between the different classes. So if I do void move player, so we want to move the player, and offset x. So that's the offset. Like if we have 1 in the offset as x, then we want to move 1 in the x dimension, and if we have 0 in y, we don't want to move in y. So now, of course, I haven't implemented this part yet, how to move, but now we can see something. If we prevent ourselves from moving here, if we prevent ourselves from changing these values, then what we can do is we can tell the user where to start. We can get the values from where you are and then just move the player. We can't teleport the player. We can just set new values, and that's good because when we want to move the player, we might do checks like, can you actually move here? When you moved here, what happens? Something like that. But if we allow ourselves to just change these values directly, then we're going to bypass all of those things, and things might work weirdly. So we want to prevent the decoder from actually changing these values directly, but indirectly you can change them using these methods, and that's sort of why we would like to prevent the user or the coder from actually changing those from outside our class, of course. Right. So when we want to move somewhere, we want to move to a specific location, right? And how do we get that? Get location at position would be something very nice to have, and then we just refer to x and then the offset, and y and then the offset, right, like that. But there's nothing called get location at position in the map here, so we could create that. So we return a location, and then we give it x and y, right. And now we could think like, alright, we just return the board y, x, like that, and it's not entirely wrong. But the problem is, what if we refer to well, if we have x minus 1, we are like at 0. The player is at 0 at the moment, and then we want to move left, for instance. So now we get 0 plus minus 1, put 2 move to the left, and then we get minus 1, and that's outside of the array, outside the board array, and then it's going to refer to an index that doesn't exist, and therefore get an index out of bounds error. And we don't want that just because the player tried to move outside of the board. We want the player to be prevented from moving there, not crash. So what we will have to do as well is actually to make sure that if the player is outside of the board, then we don't want it to return this value, because that's just going to crash us. So what we can do is board.length or x is greater than or equals to board.y.length. So my current check here is checking if we're outside the board, and if so, we can return null. That means that, well, we don't have anything here because we're outside the board, so we can use null as a value. It's nothing, it's null, but it's still quite useful to just tell it, well, we might return null from within the board, but if we're not even in the board, we can just return null directly, and then we can use that. We need to know that that's actually going to be able to give us null. We can get null from there and null from there. So that's why we need to, in the player here, when we have when we receive that location, we need to make sure that it's not null, like this, because otherwise we will get what we had before, like, oh right, you try to refer to a location that doesn't exist, you know, that's going to crash. We'll get a null pointer exception. So what I want to know is that we actually have a location to move to, as well as knowing that it's not solid. So we don't want to move into a solid location. Like if you have a big rock, I don't want to go into that because that doesn't make sense. But there's nothing called a solid here. So let's improve this very simple thing here. We have just a character of a location, but a location it's so much more than just how it looks on the map. So we could have like Boolean solid like that, and then have a Boolean is solid method where we return this. So we can use it like this. So we make sure that if it's solid and we can't move there, but if it isn't solid, we can. And we need to set this value. And I'm going to show you a trick which is going to be quite apparent what we're doing a bit later on. So I do location set solid Boolean value. Then I do solid equals value. So this is basically just the method to set the the solid state. So if it's solid or not, we can set it here. But then I return the object itself. So I have the return type location instead of void. It might seem a bit weird, but what I could do, we will see proper examples of that in a few minutes. Then what I could do if I want to have like location my new location equals new location like this, and now I can well, I need a symbol here, dot set solid, and I could do like true. So what I do now is I create a new location and then I set it solid, but when I set it solid I'm going to return the location itself, and that's why we can store it inside this variable here without a problem. But like I said, we will see proper examples of that in just a few minutes. So now when we can check if the user is going to a solid block or not, then we can make sure that, well, you can't move here. You can't move, well, there, where you try to go. But if we could move that we had a location, and the location is not solid. And remember now, since in Java if you use AND, it realizes that if the first part of the AND is false, it's not going to bother about checking the second part, because, well, for AND to be true, you need both parts to be true. So as soon as you find a false one, you know everything is going to be false together. So therefore, if we find out that move to equals false, not equals false, equals null, then we're not going to bother about checking if it's solid or not. And that's exactly what we want. Because if we had null and checked if null was solid, then we would get a null pointer exception and crash. Right. So what we could do now is actually just move the player, right? So here's our moving code. Pretty straightforward. We just change the x and y values depending on the offsets where we were moving. And finally, I'm actually going to do on player arrive. So what if we want to do something specific when a player arrives at a specific location? So then we can just add a method here. So now all of a sudden our location is so much more than just on player, than just a character. First of all, we just use it as a character, right? We might want to know which player arrived, and then we can use, like we've done before, we can refer to ourselves by using this. So this is very handy in these scenarios, because how would we otherwise refer to the current player? If so, we would need to have a variable in here to like store a field there to store who we are, but that doesn't make any sense really. So now, like I said, it's much more. First of all, it's a symbol. That's what we had before. That's just the character itself. But now we can check if it's solid or not. We can set that, and we can also do something when the player arrives. It's not just a character. If we stored it as a character, if we stored a character array and a Boolean array individually, then we would still not have a method here called onPlayerArrive, so we wouldn't be able to do anything specific when the player arrived. So that's why this class is quite handy to have. Even though it's not that complex yet, we have two different values that we need to store, one for the symbol and one for the solid, and then we also have a method here that something happens when a player arrives there. So now it's more than just a character, and that's sort of what I want to show you with this example, how you can use these classes together. Because if you don't understand when to use them, then there's no reason to know what they do, right? Okay, so now when the player can move, we might want to allow the user to tell the player to move, right? Okay, so what we want to do is print out the map and then ask the user what to do, right? But instead of typing that, I'm just going to copy that from my example here. So we just ask the player, where would you like to go? Well, up, left, down, or right. So that's 4 different options. And to answer that, we of course need to import the scanner. Oops, that's not how you spell util. Like that, and then we need to create a scanner as well. Right, and finally we can do like a switch statement here. My scanner dot next end. And the first case would be to move up. And how do we move up? Well, we have a method here in the player that tells the player, well, move accordingly to the offset. So if you want to move up, we wouldn't change x, but we would change y. We would decrease it by 1. So what we do is just do player dot move to, and then we do 0 minus 1. So that will move it upwards, right? So we don't change the x value, but we change the y value with -1. Okay, and then we can just continue with the other ones and finally get something that looks like this. So we just have move up, move to the left, then we change the x value. We have move down, where we change the y value, and finally we have move right, where we change the x value, so we increase that by 1. So now we have allowed the player to actually move in different directions. And it's quite simple to see what's going on here. We just call that method and tell the player, well, move, 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 whatever. We just tell it to move differently here. And then the player is going to be moved. Right, so let's try to move this player. It's not going to work. You can't move there. You can't move there. You can't move. What's going on? Well, we don't have any locations to move to, right? So in the condition, for obvious reasons, we make sure that we are actually moving to a proper location. Otherwise, we can't check if it's solid, and we can't tell it that the player arrived there. So at the moment, the player can't move anywhere. So how do we fix that? Well, we create the actual maps, right? And what would make quite a lot of sense is to have a way of creating an open map, like just an open space, not any tunnels inside a big system or whatnot. Just a lot of space where the player can move. So create open map, which is just going to create this map to, well, convert this map to an open map, and it's fairly simple to just do so. We started 1, so we ignore the first index because that's going to be sort of a border, and then we make sure that we loop through while y is less than border length, border length -1 to give a border on that end as well. And then for int x equals 1, so we do the same thing here. Board y dot length -1. So all of a sudden we loop through them all apart from the edges, and finally we can actually start creating things here. So we can do board, and then y, and then x, and finally a new location with a space. Like that. And if we want to, we could do set solid false. We can do that for completeness. We don't have to, because the default value is that it's not solid. But as you can see, in the set solid one, since we return the location itself, when we do this thing here, what we will return is the newly created object here, the newly created location, so we can still store it like this. So we get the value from set solid, which is the same as what we just had there. But like I said, it's not necessary because our default value is actually false. So if I now do that and refer to it up here, so now I actually define how the map should look like and compile it. We can now see that instead of having a lot of dots, we have dots as the borders, but we have an open space in the middle where we can move. Let's see if we can move. Yeah, we can. As you can see, it's flickering a bit with the console, like it has to move everything up, like the old things are here, and that's what you will have to live with when it comes to console-based games. So now what do we have? Well, we have a player that we can move around using move player. We have a map, which at the moment consists of a board of locations, but we can use handy things like print map and create open map. So these are like methods that help us use this two-dimensional location array. We will see another example why it's nice to have it as a separate class later on. And then we have this location where we have a symbol that we print out on the map, and then we have if it's solid or not, and then we can also do things when the player arrives. Right, so before the break I'm going to finish up a few more things. For instance, we might want to set the location, because we can get the location and it might be good to set the location. So set location and then int x, int y, and then the location we want to set. And what we will have to do is make sure that the same thing we did here. We need to make sure that we're actually inside the actual board when we set it, otherwise we don't want to do anything. So the one I'm going to do now is actually opposite of what I checked here. Here I check if it's invalid. Let's check if it's valid instead. And y is less than well, less than actually board dot length, and we will need to make sure that x is in the range as well, like that. So if it's in the range, then we can set it, and this is going to be used when we want to individually change locations when we just create the map at the start. Then board y x equals the location. So there you go. Right. So far we have a few new things. We are using null, and we're making sure that something, if it's null, we want to do something differently, so we don't get null pointer exceptions. We used this keyword to refer to another constructor, but we also used this keyword to send us ourselves as a parameter, for instance, move to on player arrive, or map.print map, we want to send the player along there as well, or we can use it to refer to our fields if they have the same name. We can use this.map equals map. But that's about it for this first part. We need to take a break now, and in about 15 minutes then I will continue and add some more features, and then we will see why we would use packages and scopes, which is also part of this lecture, to this program, to this game here. So like I said, that's about in 15 minutes, so I'll see you then.